You're welcome to Excellent Simplified Tutorials.
Today we're going to be talking about chain rule. And chain rule, you can also see something like function of a function. So if you see function of a function, what we are talking about is the chain rule. Now, we've looked at the formula method or the general method of differentiation. We've looked at that. So today we are going to look at the chain rule. Now, before we look at that, let's take an example. If you have something like this, before we look at chain rule properly, if you have something like this, 2x plus 1 all square, and you are asked to find, if they say y is equal to this, and you are asked to find the derivative, simply it will be very easy for you to expand this bracket and differentiate, right? Is it not? Since this is raised to power 2, it will be very easy for you to expand this bracket and find the derivative. What that means is you can simply work it this way: 2x plus 1, 2x plus 1. This is the meaning of this, is it not? This square means this top 2 times. Then you can expand. 2x times 2x will give me what? 4x what? Square, right? Good. This 2x times 1 will give me what? Plus 2x, right? Now this 1 times 2x will give me what? 2x. Then 1 times 1 will give me what? Good. So I'll be having 4x squared plus 2x will give me what? 4x. Good. Plus 1. Is it not? Now y is equal to this. So at this point now we can differentiate this. So we can say the y over the x is equal to, if we differentiate this, 2 times 4 give us what? 8, right? X raised to power 2 minus 1, which is still x, right? So we'll be having what? 8x, right? Plus, if we differentiate 4x, we'll have what? 4, right? Good. If you differentiate to 1, we'll have what? 0. In our last class, we said differentiating a constant is 0, and we proved that in our last class. So 0. So we are left with 8x plus 4. This is our answer. Simple, right? Good. What if you have something like this? What if you have something like this? Y equal to 2x plus 1 raised to power 10. And you are asked to find the derivative. If you have something like this, 2x plus 1 raised to power 10. You know, this means 2x plus 1, 2x plus 1, like that, 10 times. Is it not? Will it be very easy for you to expand the brackets? It will not be easy, right? I bet you'll be expanding until your notebook will be filled up if you are expanding with this. So you see that this method will not work in this way. You cannot expand here before you find the derivative, just like we did here. So in this case, it will be very easy for us to use the chain rule here. That is where the chain rule comes in. Because if you want to expand the bracket, we'll keep on expanding, and we exhaust our time, we exhaust our book. So to make things simple, we'll use the chain rule to do this. So can we go to the chain rule now? Any question before we go on? So do you know why we want to use chain rule now? Because if we decide to expand this bracket, now raised to power 10, what if it's raised to power 100? You just be expanding. It will take your time and it will take your book. So we'll decide to use the chain rule to make things easy. So look at that today. What did we use before? X plus 1. You said the number, it was 2x. 2x plus 1. Let's go with that. Okay, so let's look at example 2. Example 2 says, if y equal to x plus 1 all raised to power 10, find the y over the x. Find the derivative. Now, in this case, nobody will even tell you to use chain rule, because if you want to expand, you expand and expand and expand and expand. This is raised to power 10. So, using chain rule, we are given that y is equal to what? X plus 1 all raised to power 10. Good. The first thing is, use a dummy variable to represent anything in the bracket. I like using u. So we can say let what? Let u represent what? X plus 1. So u is equal to x plus 1. Anywhere you see x plus 1 is what? U. Is it not? This implies that y is equal to, everything here is now what? U, right? So I'll be having y equal to u raised to power what? U raised to power what? 10. Do you understand? Y equal to u raised to power 10. Now that we've gotten this, remember our formula? The y over the x, which we are asked to find, is equal to what? The y over the u times what? The u over the x. Have you noticed that if the u cancels this the u, you will still be left with the y over the x? The u can cancel the u. So this is equal to this, actually. Now, let's find the y over the u. The y over the u, differentiate y with respect to u. This is y and this is u. So we are asked to differentiate y with respect to u. So this is what we are differentiating. And if you differentiate u raised to power 10, you have what? 10 u raised to power what? 9, right? Good. So the y over the u is equal to 10 u raised to power 9. Good. Let's find the u over the x. The u over the x is equal to, now differentiate u. Where is it? Differentiate u with respect to x. Remember we said u is equal to this, right? We said this is equal to u. That was what we said. So you are differentiating u with respect to x. If you differentiate x, what do you have? 1, right? If you differentiate x, you have 1. Plus, if you differentiate 1, you have what? 0. So everything here is what? 1. The u over the x is equal to 1. Good. Let's substitute in the formula now. The y over the x, is equal to, now the y over the u is what? The y du is what? 10 u raised to power what? 9, right? Times the u dx is what? 1. So we are left with 10 u raised to power 9, right? But recall that u is equal to what? X plus 1, right? So we'll just have 10 u is what? X plus 1 raised to power what? Here's our answer. Here's our answer. Is it not simple? Put it together. Now, example 3. If y equal to 4x minus 3 all raised to power half, find the y dx. Now, just like we said, let u be equal to what? Everything in the bracket, right? So if you have it, let u represent 4x minus 3. Let u represent 4x minus 3. This implies that y will be equal to what? Everything in the bracket is now u. So y will be equal to u raised to power what? Half. Is it not? And remember that the y over the x is equal to the y du times what? Du dx. Good. So let's solve individually now. The y over the x over du, the y du is equal to what? Now dy du. You are differentiating y with respect to u. So if you differentiate this, what do you have? If you differentiate this, you have what? Half u raised to power what? Remember, if you have this, u raised to power half. If you are differentiating, you bring this here, right? So you have half u raised to power half minus 1, is it not? So you'll be having half u raised to power what? Half minus 1 is what? Minus half, right? Minus half. Good. So if we differentiate this now, u raised to power half, we'll be having half u raised to power what? Minus half, right? But you agree with me from the laws of indices that this is same thing as saying half times 1 over u raised to power half. Because some indices were told that to remove negative here as a power, you do 1 over the positive index. Is it not? So this is same thing as this. And you agree with me that this is same thing as saying 1 over 2 times 1 all over square root of u. Because from the laws of indices, when you have half as the index, as the power, it will turn to square root, right? So u raised to power half is the same thing as square root of u. Is it not? Praise raised to power half is equal to what? Square root of what? Praise. Anything raised to power half, square root of that thing from indices. Please, if you missed that class, go and watch the video. Now, this is same thing as saying 1 times 1 will give me 1, right? So 1 over 2 times this will give me what? 2 root u. So this is the y over the u. Next, the u over the x, the u dx, if you differentiate u with respect to x, what do we have? If you differentiate 4x, what do you have? 4, right? If you differentiate 3, what do you have? 0. So the u dx is equal to what? 4. Good. Then you substitute in the formula. Dy over the x is equal to, now dy over du is what? Dy du is what? 1 over 2 root u times the u dx is what? 4. So we'll end up with 4 times this is what? 1 times 4 will give us what? So we'll be having 4 over what? 2 root what? U, right? 2 can go here 2 times, right? 2 go here out. So we'll be having 2 over what? Root u. Is it not? But remember that u have value of what? 4x minus 3, right? So if we substitute that into this formula, we'll be having 2 over what? Root what? 4x minus what? Here's the answer. Chain rule is very simple. Just follow the procedure.